Welcome back to our continuing discussions of JavaScript. This time we're going to take a look at Boolean evaluation and how JavaScript gets the concept of truthy. So Boolean type coercion. Since JavaScript has dynamic types, type coercion is common in the language. So when one data type will flow smoothly into another and back again without too much programmer intervention. Type coercion is the automatic conversion of one data type to another. In Java and C#, there's an example of this when toString, what happens when an object is used in the context of a string type. That's a type coercion, but those types of type coercions aren't common in those languages. For the most part, the programmer has to explicitly call conversion methods in order to get types to convert from one to the other. In JavaScript, those data type conversions happen without programmer intervention. They happen implicitly, and that's known as type coercion. So type coercion also happens in Boolean evaluation in JavaScript, not surprisingly. And that type of conversion leads to the concept of falsy and truthy in JavaScript, kind of a gray area for JavaScript that doesn't exist in other languages where true and false are clear-cut values. So falsy is when false is evaluated, null, undefined, 0, -1, 0n, not a number, and empty strings are evaluated in the context of the Boolean expressions. So notice that these certain values are all different data types. There's null, which is the data type of object, but it's really a primitive. Undefined, which is data type undefined. 0, number. Not a number, which is a number. 0n, which is a big int. These are all types of type coercion in the context of a Boolean evaluation that come out as false. Truthy is defined as everything else. So it's defined in terms of falsy. So falsy is this handful of values, and truthy is when any other JavaScript expression is in the context of a Boolean evaluation and it comes out to be true. So we're going to take a look in Chrome Developer Tools at this happening and look at some difficulties that arise because of this implicit type. So I'm in my blank page in the Developer Tools. I'll bring up the console. And I'm going to write an if expression here. If true. We'll just fill it out. It's seen that before. So we'll fill that up there, and we'll run it. And to run it, you just hit enter. So it evaluates to true. If true, console log.true. So we'll up arrow and change this to false. This shouldn't be too surprising. We should see false print out then. And there it does. So let's take a look at some type coercion cases. So null, as we saw, is a data type of an object, but is really a primitive. That evaluates to false. So we're looking at explicitly falsy examples. A number type of 0. An empty string. Straightforwardly evaluated as false. So let's look at some truthy values. Anything that's not anything that's not explicitly defined as false. So a non-empty string containing the character false is converted to true, and it's true of any non-empty string. Type coercion means it's true. Empty curly braces, that declares an object in JavaScript, an object that has no properties. And that's also evaluated as true. Here's how you declare an array in JavaScript. Also true. So type conversion, truthy and falsy. Let's look at some combinations where we might get some unexpected results. How about this? Nothing unexpected there. Truthy and true, a Boolean, a direct Boolean true, they both evaluate to true, true and true. How about this? And this is where that implicit type conversion comes in to a difficult case. Because what's on the left-hand side is evaluated as truthy, we can compare it to true, and the resulting value is false. There are tables that define this behavior. You can look them up. But when you have to look up a table in order to understand the the value of an expression, then you have a pitfall in the language that you can easily fall into. Again, you're going to get used to, if you program a lot in JavaScript, implicit type conversions happening all the time. You're used to a fluid and dynamic type system. So expressions like this can lead to unexpected behavior. Here's another case that might seem surprising. On this side, we'll have the number 3. Oops. And on this side, we'll have the string 3. Okay. So that evaluates the true. And that's because there's type coercion going on. In this case, type coercion going on between the string and being implicitly converted into being a number and then evaluated as true. Now, this is what's recommended in JavaScript. The equal will do that truthy and falsy and type coercion in order to do comparisons. This is an exact comparison. In other words, it requires that the equal comparison operator requires that the type be the same in order for the value to be considered to be true. So that's defined as false. So in general, in order to avoid ambiguity in JavaScript, use the triple equal version of the comparison operator over the double equal in order to avoid subtle problems with type coercion into Booleans.